Good morning, students. Today we will see some topics from Unit 4 of Distributed Systems, and we focusing on algorithm for synchronous checkpointing and recovery. So, in the previous video also we discussed about checkpoints. So, checkpoints means nothing but the same state is called a checkpoint, and the procedure of restarting from a previously checkpoint state is called rollback recovery. So, here we are going to see this one algorithm, that is synchronous checkpointing algorithm. Basically, it's developed by scientists Juan and Venkatesan. So it is also called as Juan and Venkatesan. Sorry, Juan and asynchronous checkpoint algorithm. Okay, actually, this algorithm helps in recovery in asynchronous checkpoints. So there is no synchronization, and the assumptions are so we are actually have any algorithm we need to have some assumptions, right? So here also we are going to focus on the various assumptions, then how exactly the log storage types happen, then notion and data structure, then we will directly go into the algorithm. Okay, so now the major assumption here is the communication channels are reliable. Delivery messages is definitely in FIFO order, that is first in first out order. Then we can say that there is an infinite buffer. So any number of messages we can keep on put it in a buffer. Message transmission delay is arbitrary but finite. Okay, so these are the assumption we are maintaining when we are dealing with the Zhuang and Venkatesan algorithm. The underlying computation or application is usually event driven. When a process P is at state receive message M, it process the message, move to state S, and send a message out. So we can say that there is a sender of message, receiver of message, and the message recipient broadcast message. So these are the components we are having. And communication channels have no buffer size limit, that I already mentioned, and there is a bounded message transmission delay, and underlying system is event driven with locally timestamped monotonically increasing number of events, each event consisting of wait for message, process the message, change process state, and send a number of messages. So these are some of the basic preliminary things we need to focus behind this. And again, another one important thing is we have two types of log storages are available. One is a volatile log, another one is stable log. So in volatile log, it takes short time to access but lost if processor crash. The content of volatile log are moved to stable log periodically. But in stable log, what will happen? Longer time we can keep it and we can able to access it. But even though the system crashed, still we can able to recover the contents. Okay. Then so the basic idea, so the actual recovery algorithm here is at each event, a triplet of message, that is S, M, message sent, is put in the log file. S is the state, M is the message which causing the event, and message sent is the sent message set of messages as of now sent. So these are the three components we are going to keep it in a log file, and we are using the two data structures. One is the receive and message, and another one is send message. So in the received message, we are having received of I, J, checkpoint. That is the number of message received by processor I from processor J at checkpoint. Similarly, sent I, J checkpoint. This means the number of message sent from processor I to processor J at checkpoint value. So use this message or send or receive count. We can determine whether we need to do perform rollback or go on. Okay, so this is the basic idea, and the algorithm. So the algorithm actually, I will say the sequence of steps in the algorithm. So what exactly we are doing is, we have to find the set of consistent checkpoint from the set of checkpoints. So several checkpoints will be there. We need to identify the consistent checkpoint. That is our primary goal, and we can able to do this with the help of identifying the total number of send message and receiving message. Recovery may involve multiple iteration of rollbacks by processors. Okay, so we can do number of iterations so that we can able to get the final value. When a processor rollback, it is necessary for all other processes to find out if any messages sent by the rolled back processes have become an orban message. So the an orban message are identified by computing the number of messages sent to the processor and received from the neighboring processes. When a process restarts after a failure, it broadcasts a rollback message that it has failed. The recovery algorithm at a processor is initiated when it restarts after a failure or what to say when it lands that there is a failure in the another processor. Because of this broadcast of rollback messages, the recovery actually initiated by all processors because everybody getting the message rollback, so automatically they are all start initiating the recovery algorithm. Okay, so this is the way we can save the from unnecessary crashing. So this is what actually these steps are actually represented in this diagram. So here the main important thing is with each iteration, at least one processor will roll back to its final recovery point unless current recovery point is consistent. So still, we are once it is consistency, we can stop the algorithm. So this is what Joan Venkadeshan algorithm, and it is one of the excellent algorithm for synchronous checkpointing and recovery. Thank you for listening.